Hello, DDP students. In this tutorial, we're going to be talking about tolerances. This takes place in a manufacturing process and has to do with the dimensions that are sent to a machine to produce a part. So let's just say, for an example, we want to send a cube to be made to a machine, and the height is 1 inch, the width is 1 inch, and the depth is 1 inch. When we send it to the machine to be made, when it is actually made, it is highly improbable that the actual cube is going to be exactly 1 inch by 1 inch by 1 inch. It could be smaller or larger by a tenth, a hundredth, a thousandth, or even more than that. The reason for this is both machine and human error. It could be that a drill bit is stripped or worn out and, just not producing an exact part, but there are many, many reasons why a part doesn't come out to the exact dimension that is sent to the computer, or machine, that is. And for that, what we do is we put tolerances on dimensions. And what tolerance is the acceptable amount of variation on a dimension. So meaning that we're telling the machine how much larger or smaller a part can be and still fit into another part, or be used the way it was meant to be used. So tolerance is a rule of dimensioning. Every dimension must have a tolerance. And so we see example of different tolerances here that are added to the dimension. And yeah, so we are going to take a look at 3 different types of tolerances. And these tolerances, again, tell how much larger or smaller a part can be when it's manufactured. So let's take a look at this. So we have, let me just try to get a larger view here. So our 3 tolerances are right here at the bottom. We have bilateral tolerance, unilateral tolerance, and limit dimensions. So we're going to take a look at the first one, and this is going to be these numbers here. Okay, we have a 1.03 and a 1.01, and you'll notice that they're stacked on top of each other, just like this. This is an example of limit dimensions. And what this is telling us is that this is exactly how large it can be, and this is how small it can be. Okay, so the part can be no larger than 1.03 and no smaller than 1.01. So when we're figuring what the tolerance is, we're going to be taking the difference between the two. So that is going to be 0.02. 0.03 minus 0.01 is 0.02. So that will be the total tolerance when we are looking at this. So another example can be found here. Can you find another example of limit dimensions? I'll give you a moment. Okay, if you said this over here, 1.53 and 1.50, you would be correct. So this is another example of limit dimensions. The tolerance is 0.03. This part here can be no larger than 1.53 and no smaller than 1.50. So we're going to take a look at a second example. Get rid of this here. Okay, so what we want to look at here is this here. We have a 2.5 with a plus sign, 0.03, and a minus 0.00. So this is unilateral tolerance, and the signature trademark of unilateral tolerance is zeros here. The zeros can appear in the plus or the minus sign. And what this is saying is that it can either get larger in one direction or smaller in one direction, but it's not going to be both. So this part can be 0.03 larger than the 2.5 dimension. It can be no larger than 2.53 but it can't be any smaller than 2.5. All right, so it's only getting larger, but no smaller. So unilateral tolerance only gets bigger in one direction or smaller in one direction, but not both, which we'll get to in the next one. So can you find another example of unilateral tolerance? I'll give you a moment. Okay, if you said this right here, you would be correct. So we have a 1 inch, and the plus sign here are the zeros, and the minus sign is 0.02. So this means that it can't be any larger than 1 inch, but it can be smaller by 0.02, meaning that this can be either 1 inch or 0.98. All right. And so the tolerance of this would be 0.02, and the tolerance for this would be 0.03. So it's whatever it gets smaller or larger, whatever that amount is going to be the total tolerance. And so we are now going to move on to our next tolerance. Okay, and that is going to be, found right here. And we're going to circle this. So what we have here is this 1 inch, and we have a symbol that is plus minus. So this plus minus right here, 0.02. So this is bilateral tolerance. And what this means is that this is going to be getting larger and smaller by the exact same amount. So this can be 1.02, and it could be as small as 1.98. So when we have a bilateral tolerance, we add it in both directions. So it would be 0.04. Okay, so the 0.02 larger and the 0.02 smaller would make it that way. Okay, so we're 0.04. So the signature trademark of this tolerance is the plus minus sign. So just to go over this, the signature trademark of a limit dimension is that two numbers are stacked on top of each other. The signature trademark of a unilateral tolerance is that it is getting larger in one direction or smaller, and there's a set of zeros. And the signature trademark of a bilateral is this plus minus sign right here. So we are going to be looking at tolerances that don't have a dimension on it. So one of the rules of dimensioning is that every dimension must have a tolerance. So if it does not have a tolerance, so let's just take this 1.5, let's just circle that, this 1.5 here, this 2, and this 0.4. When it does not already have a tolerance on it, we want to go to our general tolerance table. And what we want to do is we want to look at how many places are after the decimal. So we have a certain amount of tolerance where there's only a tenths place here after the decimal, a different one for when it's hundredths, and one where it's a thousandth. So if we were to look at the 1.5, which has 2 places at the decimal, we would be looking at this right here where there's 2 places. So this is going to be getting as large as 1.52 or as small as 1.48. And that would be a total of 0.04 tolerance. If we are looking at this 2 here, there are 3 places after the decimal. So this can be as large as 2.001 or as small as 1.999, and the total tolerance for that would be 0.002. For this 0.4 here, we would use this one here, which only has the tenths place after the decimal. So this can be 0.5, as large as 0.5 or as small as 0.3. And the total tolerance would be 0.2. So these are going to be how you do your classwork by looking at these trademark tolerances, these 3 tolerances, and we're going to be looking at what we're going to be doing for our classwork in the next video. But these are the 3 tolerances: bilateral, unilateral, and limit dimensions. And this is how you find the tolerance when a dimension does not already have one. So I'll see you in the next tutorial to explain the classwork to you. See you there.